Right. So in last classes we discussed about heat flow and work interactions for all 5 types of process, right? So I request each and everyone please note down the formulas so that we will solve problems now. Is the screen is visible to all of you?
Yes.
Yeah. Just make a
Sir,
note or
sir.
make a note or take a screenshot. So we discussed each and every process, work done as well as heat rejected or heat received. So let us say in case of constant volume process, for constant volume process, volume is constant. Therefore, change in volume will be zero. Once change in volume is zero, then work done will become zero because work done is equals to integral P dV.
V.
Right. And in the absence of work done, heat supplied is equals to change in the internal energy. Right. U2 minus U1 means the heat whatever we are supplying is used to increase the internal energy. U2 is greater than U1. Therefore, the heat supplied in case of constant volume process is used to increase the internal energy of the system. Next, we discussed about isobaric or constant volume process. So for that, W equal to PdV, that is equals to P into V2 minus V1, right? And the heat supplied, we know that that is equals to H2 minus H1. From constant volume process, we are going to define specific heat at constant volume CV. CV is equals to du by dt. If you remember, du by dt. And from constant pressure process, we defined enthalpy, and Cp is equals to dH by dt. Cp is equals to dH by dt. And then isothermal process work done equal to PV log V2 by V1, or we can also written as PV log anything base E can also be written as ln V2 by V1.
Sir,
Log, yeah.
sir, in CP, dH by dt means change in enthalpy. dH means?
Change in enthalpy with respect to change in temperature.
Yes.
Change in enthalpy with respect to change in temperature.
Oh.
Okay. Then
Yes.
adiabatic process means it is isolated one, right? There is no heat interaction between the system and surrounding. For adiabatic process, heat supplied equal to zero. In the absence of heat supplied, right? So what is the work done? Work done equal to this one. This is also equal to dou W is equals to du. Okay, so as we know, dou Q minus dou W is equals to du. In the absence of heat supplied, dou W is equals to minus du. Means during adiabatic process, in the expense of internal energy, work is going to done. In order to do the work done, internal energy is going to utilized. Means during the adiabatic process, internal energy is decreased. That is the meaning minus dou W. Okay. And then in the same way, we discussed the polytropic process, that is P1 V1 minus P2 V2 by n minus 1. Same as adiabatic process, only index is going to change. Here gamma is replaced by n. Gamma is replaced by n, you will get the work done. Then we discussed heat also. So that is nothing but gamma minus n by gamma minus 1 into work done. Into work done. What is W12 to W12 is P1 V1 minus P2 V2 by n minus 1. Okay. So these things are already discussed, right? We will start problems now. Is it okay? Any doubt in the formulas? Please let me, so that I will explain.
No.
You should be aware of all these formulas. You will get one derivation pakka for the exam. Please respond.
This sir.
Right. Now let us take a problem. Right. Let me copy the problem to the pane. Right. A closed vessel contains 3 kg of carbon dioxide. Right. Let us, what is given? Mass is equals to.
What is the page on the picture?
Yeah, somebody unmuted. So given that mass is equals to 3 kg and pressure is equals to 70 kilopascal. Is it is visible what I am writing on the pane?
Yes.
Yes, sir.
Right, 70 kilopascal. So that is equals to 70 into 1 kilo is 10 power 3. 1 pascal is
10 power.
1 Newton per meter square. Okay, 1 pascal is 1 Newton per meter square, and temperature T is equals to 300 Kelvin. T is equals to 300 Kelvin. Then heat is supplied to the vessel. So heat is supplied to the vessel till the gas attains 140 kilopascal of pressure. Means P1 is 70, P2 is 140. This is P1. Then P2 is equals to 140 kilopascal. So he added 8. So 140 into 10 power 3 Newton per meter square. Now tell me which type of process is it is. This is the data given. So what is meant by closed vessel? Which is constant for
Constant volume.
very good, very good. So closed vessel means it is the constant volume process. So given that it is the constant volume process. Right. Now what is asking? Calculate first one, final temperature, right? Final temperature. Now tell me, for constant volume process, what is the governing equation? P by T
P1.
is equals to constant, right?
Yeah.
P by T is equals to constant. Therefore, P1 by T1 is equals to P2 by T2. Can we write like this? Right. So now this is T is nothing but T1. At temperature, T1 is the 300 Kelvin at pressure P1.
Sir.
Now heat, yeah.
Sir, we have to change in centigrades or
No, Kelvin only. Anyhow, it is the ratio.
Yeah, yes.
Anyhow, it is ratio, right? When Q is added, its pressure is increased. At the same time, temperature is also increased. What he is asking, that temperature, right? So from this, I can write T2 is equals to P2 by P1 into T1. Agree? Please respond.
Yes, sir.
Now tell me, if you substitute all the data, what you will get? T2 is equals to P2 value is 140 into 10 power.
Temperature
600.
600 kelvins.
Okay, very good. 70 into 10 power 3 into 300. So this is 10 power 3, 10 power 3, 71 ja, 72 ja, 72 times it will go 2 into 300, that is equals to 600 Kelvin is the temperature T2. That is the first bit. Is it clear?
Yes.
Now, what is the second bit? Work done on or by the gas, right? So for constant volume process, what is the work done?
0.
0.
Very good. dV is equals to 0, which implies W is equals to integral W1 to 2 integral P into dV, that is equals to 0. Right. Second bit is also over. Now, third bit. Heat added. Right. So in order to calculate the heat added, we know that from first law of thermodynamics, dou Q minus dou W is equals to du. As we know, for constant volume process, work done is equals to 0, which implies dou Q is equals to du. Right now? So
Yes.
how to calculate dou Q? M into CV into dt. Agree? For constant volume, sorry?
MRDT.
MCV dt.
MCV.
Dou Q equal du. Yes or no?
Yes.
This is constant volume process. Okay. And mass is given how much? Mass is given as 3 kg.
3 kg. Yes, sir.
3 kg. And CV value? CV value is given 0.65 kilojoules per kg Kelvin. So CV is given 0.65. Let us convert into joule per kg Kelvin into temperature difference. T2 minus T1, 600 minus 300. This is equals to 300, right? So if you calculate, you will get in terms of joules. Because 0.65 is kilojoule. Kilojoule is converted into joule by multiplying 10 power 3. So therefore, this will be joule per kg Kelvin. This kg and this kg will be cancelled. This Kelvin and this Kelvin. So you left with only joule as the unit. How much this value? Please tell me.
585 into 10 power 3 joules.
585 into 10 power 3. Very good. 585 into 10 power 3. I can also write it as 585 kilojoules.
Yeah.
Right. So this is the third bit. Next, what is the fourth bit? Heat added is over. Now change in the internal energy, right now? So what is change in internal energy?
MCVDT.
Very good. Same value. du is equals to u2 minus u1, that is equals to m into cv into dt. That is what we calculated. So 585 kilojoules means for constant volume process, heat added is equals to change in the internal energy. Clear
Sir,
this one? Tell
sir,
me. Yeah.
for mass we have to use in kgs only, sir.
Yeah.
We don't.
Always SI unit for mass is kg only. Anyhow, it is given in kg only.
Yes.
Kg only given. Right? And this CV value is related to this particular gas. The CV value related to this particular gas, CO2. Is this problem is clear? Any doubt, please ask me. So we calculated final temperature, work done, heat added, change in internal energy.
Yes.
Right. Can I move to next problem?
Yes, sir.
Right. So this is what we discussed now. So we got 600 Kelvin, and we got Q3 is 585 as well as internal energy change in internal energy is also 585. And work done will be 0 because no change in the volume. Now next problem we'll see. Right. Let me copy the problem. Yes, please mute your mics. Actually, I am working from home, so maybe due to the my laptop is slow, it will be delayed. Now, can you see the problem? Hello? Can you see the problem now?
Yes, sir.
Yes, right now. So an ideal gas requires 1150 kilojoules per kg of heat to raise the temperature from 20 degrees to 100 degrees centigrade when heat added at constant pressure. Let me write first data. Right, heat required is equals to 1150 kilojoules per kg to raise the temperature from 20 degrees centigrade to 100 degrees centigrade when at constant pressure. Right now, when heat is supplied to the same gas at constant volume, the heat required is 825 kilojoules. So now if it is the process is taking at constant volume, heat is 825 kilojoules per kg, 825 kilojoules per kg for the same temperature rise. T1 is equals to 20 degrees centigrade, T2 is equals to 100 degrees centigrade, but the process is taking place at the constant volume. Okay, so what he is asking, determine the specific heat at constant pressure, constant volume, adiabatic exponent, etc. Right, now tell me how to solve this problem. Can anyone please respond how to solve this problem? So he took two processes here, constant pressure as well as constant volume process. So during constant process, in order to increase the temperature from 20 to 100 degrees centigrade, he required this much amount of heat. Whereas if the process is carried out constant volume process, in order to increase the temperature from 20 degrees to 100 degrees centigrade, he required this much amount of heat. Okay, right. Now tell me, during constant pressure process, what is Q? Constant pressure process, what is Q? Please
H2
respond.
minus H.
Yes.
MCP.
For constant pressure process, Q is
Q is
equals to M
MCP
into Cp into
DT.
dt, right? So Q is given
Yes, sir.
and mass is not given. It is nothing but Q by M. Yes or no? Kilojoules per kg, nothing but Q by M. This is nothing but small q. Specific heat is given. Because the units are kilojoules per kg, therefore this is Q by M. So therefore this equation can be rewritten as Q by M is equals to Cp into dt.
DT.
Okay. Now from this we can calculate Cp value. So
Yes,
this
sir.
is nothing but small q, Q by M. Cp is equals to small q by dt. Right. Whenever there is a temperature difference, whether you convert it into absolute unit or not doesn't matter. Right. So for example, 20 degrees centigrade is equal to 293 Kelvin and 100 degrees centigrade equal to 373 Kelvin and dt is equals to how much? Dt is equals to how much? It will be again
DT equals
80 Kelvin. Yes or no? 80 Kelvin.
yes,
If
sir.
you take a 20 degree, 100 degree or 373, 293, the difference remains same, 80, right? So therefore Cp value is equals to, if you substitute this value, Q is how much given? 1150 by 80. How much this value? 1150 by 80. What is this value?
14.3.
14.3
3
kilojoules per
kg.
kg Kelvin.
Yeah.
Kilojoules per kg Kelvin. So this is Cp value. In the same way, for constant volume process, we can write for constant volume process, Q is equals to M into Cv into dt.
Yes.
And from this I can write Q by M, nothing but small q is equals to Cv into dt. From
Yes.
this we can write Cv is equals to Q by dt. But during constant volume process, heat is only 825. There is no change in the temperature difference, same value 80. What is this value? What is this value?
10.3.
10.3 kilojoules per kg Kelvin. We got Cp value and Cv value. Next, what is asking third bit? See, Cp value is over, Cv value is over. Now, adiabatic exponent, right? So, adiabatic exponent is nothing but adiabatic exponent gamma. It is the ratio of Cp to the
Cp.
Cv. Adiabatic exponent gamma is equal to the ratio of specific heat at constant pressure to the specific heat at constant volume, that is equal to 14.3 by 10.3. How much this value? What is this value?
1.38.
1.38. No units, right? It is the ratio. Okay. Next is asking after adiabatic exponent, characteristic gas constant. Characteristic gas constant means R or R not?
R.
R, very good. So gas constant R is equals to, that is the difference between specific heat at constant pressure and specific heat at constant volume, Cp minus Cv, that is equals to 4. Units
Yes.
will be kilojoules per kg Kelvin.
Sir, universal gas constant, sir.
Yes,
R
no,
means.
no. R means gas constant.
Uh,
R naught means universal gas constant.
Sir, universal gas constant value is 8.31. That's
Very
all.
good. 8.314 kilojoules per kg Kelvin. So that is denoted with R naught or RU, depends on textbooks. This value is 8.314 kilojoules per kg Kelvin.
Sir, there is no value for gas constant, sir.
No value means this is the gas constant depends upon the gas.
Yeah. Yes.
R
Yes.
value depends upon the gas, but R naught is constant for any gas.
Yes.
Right? And what is the relation between R and R naught? R is equals to R naught by M. Agree? Right now. R is equals to R naught by M. What is M value?
Molecular mass.
Molecular mass. So M is equals to molecular mass. So that is equals to R naught by R. I think that is the next bit. I think molecular mass only. Let me see. Right. And also molecular mass of the gas. This is also required to calculate.
Yes.
Right. So molecular mass of the gas is R naught by R. So that is equals to R naught value is just now sorry, R naught is constant 8.314. R just now we calculated, that is 4. What is this value? 2.31. 2.31. No units, right? Molecular mass. Clear this problem?
Yes.
Right? So very important problem. So we are calculating first specific at constant pressure for constant pressure process, and we calculated specific at constant volume CV, that is for constant volume process. Once you know CP and CV, the ratio of CP to the CV is called adiabatic exponent, and the difference of CP and CV is called gas constant. And as we know, the relation between R and R naught. So very important throughout our 4 years. Not only this subject, any subject, this relation is very important. Most of the people will get confused between R and R naught. Okay, R naught is universal for any gas, but R is specific to the gas.
Yes.
R is specific to the gas. Okay, right? We'll go to the next problem. Right. Let me copy the question to the paint. Is it visible problem? Please respond.
Yes,
Anyone?
sir.
Is this right now?
Yes.
So
Yes.
just let me read the problem. Right, 1.5 kg of nitrogen. Right, let me write the data given one by one. Solution. So mass is given. Mass of the nitrogen is 1.5 kg, contained in a cylinder at a pressure of 6 bar. So P is equals to 6 bar.
6.
Convert the units bar to Newton per meter square. 1 bar
6.
is equals to 1
10
into
power
10
5.
power 5 Pascal. That is equals to 6 into 10 power 5. 1 Pascal is nothing but Newton per meter square. Right? And temperature T is equals to 300 Kelvin. And temperature 300 Kelvin expands 3 times to its original volume. 3 times to its original volume, right? So let us say original volume V1 is equals to V, then V2 is equals to 3V. You can see, right? I expanded it at the cylinder 3 times to its original volume. So
Yes.
V2 will become 3V. Assuming expansion process is isobaric. Isobaric means what? Which type of process?
Constant pressure.
Constant pressure process. Indirectly, isobaric means it is the constant pressure process. This is the data given. Make calculations, initial volume, everything, right? Now pressure is given, mass is given, and R value of this particular gas is given, right? So let me write R value. R is equals to 295 joules per kg Kelvin, right? Now first calculate initial. How to calculate initial volume? You know pressure, you know mass, you know R and T. So T is nothing but T1 only.
PV equal to MRT.
Very good. From equation of state, the name of that one is called equation of state. From equation of state, we have PV is equals to M into R into T. From this, for state 1, P1 V1 is equals to MRT1. So V1 is equals to M into R into T1 by P1. So all the data is with us. M is there. R directly joules per kg Kelvin, need not to convert. Only T1 is also, it is in absolute unit, need not to convert anything. Just substitute the values. So mass is 1.5 into R value 295 into temperature 300 Kelvin divided by pressure is 6 into 10 power 5. What is this value? Volume, tell me.
0.221.
Very good. 0.221 units. Units I want.
Units meter cube.
Meter cube, right? Anyone want how to write the units? Need not to remember anything. Let me balance the units.
Aisha,
Right. So what are the units for the mass? Mass is
Mass
in kg. Kg. R is in joules per kg Kelvin into temperature is
Kelvin.
Kelvin. Okay. Divided by pressure units are Newton per meter
Meter.
square. Right. Now if you see here, where is my cursor? Right. Now this kg, Kelvin cancel. So this is left with joule. 1 joule is called 1 Newton meter
Yes, sir.
divided by Newton per meter square. Again, Newton will be cancelled. You left with meter cube. That is the unit for the volume. Clear now? Once
Yes.
you know initial volume, what is the final volume? V2 is equals to 3V1, 0.663 meter cube.
Meter cube.
Next, what is asking? Initial volume, then final temperature. Final temperature. The process is constant pressure process. Right? For constant pressure process, V1 by T1 is equals to V2 by
T2.
T2. Therefore, T2 is equals to V2 by V1 into T1. V2 by V1 is 3 and T1 is 300. Huh?
Yeah.
Yeah, T1 is 300, V2 by V1 is 3. So therefore, the final temperature T2 is equals to 900 Kelvin. T2 is equals to 900 Kelvin. Clear this one? Right. How I wrote this value V by T equal to constant? Please tell me. What is the basic equation to write this equation?
At constant pressure.
Yeah, means before that, any fundamental equation for any process
PV
is
is equals to
PV equal to MRT. When
Yes.
P is constant, R is also constant, right? R is all and M is equal to unity. Then V by T is equals to constant. For any process, you can use equation of state as the basic equation. Okay.
Yes.
Now, after getting final temperature, next what is asking? Work done by the gas, right? How to calculate work done during constant process? Work done is equals to P into V2 minus V1. P into V2 minus V1. Yes or no?
Yes.
So P is given. How much P value? That is 6 into 10 power 5. 6 into 10 power 5. This is Newton per meter square. And V2 minus V1. V2 is equals to 0.663. 0.663 minus 0.221. How much this one? This value is in meter cube. Right.
265.2 into 10 power 3.
465.265.
265.2.
265. Okay. 265 into 10 power
265 in 0.2 into 10 power 5, sir.
10 power 5. Units are Newton.
Sir, here 265.2, sir.
Okay, 0.2 is okay. Newton meter will be there. This is meter square and it is meter cube. So we left with meter. 1 Newton meter is nothing but 1 joule, right? So I can also written as 265 into 10 power 2
kilojoules.
kilojoule. Right, next, after work done, what is asking? Heat added, right? So as we know from first law, dou q minus dou w is equals to du, right? Now dou q minus
Yes.
dou w is equals to du. From that, what can you write? Heat added, dou q is equals to
Dou
dou q is equals to m into cp into dt for constant pressure process. Yes or no? For
Yes, sir.
constant pressure process, m into cp into dt, m value is 1.5, cp value is how much it is given? Cp 1.05. 1.05 into 10 power 3. This is joules per kg Kelvin. And here it is kg, 1.5 kg. Into temperature difference, how much it is? T2 we got it as 900, T1 is 300. So therefore temperature difference is equal to how much?
600.
How much it is?
600.
600 Kelvin. Right now? Now balance the units. Kelvin, kg, kg will be cancelled. You left with joules again. What is this value?
945 kilojoules.
945 into 10 power 3. You got it, right? 10
Yes,
power
sir.
3 joules. That is equals to 945 kilojoules. So heat added is there, right? Next he is asking work done, internal energy, right? And change in the internal energy. Change in internal energy. How to get the change in internal energy? From this
MCD.
equation, yeah. From this, anyhow, in this equation, you have dou q, you know, dou w, you know,
Yes.
right? Right. So du is equals to dou q minus dou w. What is dou q value? Dou q value, you got it as 945. Units are kilojoule. And dou w, you got it as
265.
265.2. Yes or no?
Yes, sir.
I think this is 2.65, right? Please check this value once again.
Which value, sir?
This value, it is 2.65 into 10 power 5.
Work done.
Ah,
No, sir.
check it once, check it once. Because this is 0.666. For this only, it will 10 power 3 will go. Please check once again.
Yes.
Means this is only 265 kilojoule. Please check your answer once again.
It's right only, sir. 265.2 into 10 power 3.
265 point
2 into 10 power 3.
10 power 3, that is joule. Right now. This is correct only. Earlier it is 265.2 into 10 power 3 joule, right?
Yes, sir.
That is equals to 265.2 kilojoule. Okay, now 265 kilojoule. So substitute that value, 265 kilojoule. What is this value now? Tell me.
680.
680, around roughly 680 kilojoules is the internal energy. Clear this problem?
Yes, sir.
Right. So what we calculated? We calculated initial volume by using equation of state. Then by relation between temperature and volume, we got final temperature. Then we calculated work done by using P into V2 minus V1. Then heat added equal to M into Cp into dt because it is constant pressure process. Then change in internal energy is nothing but difference between heat supplied and work done. Okay. Let's go to the next problem. Right. Next problem. Just go through the problem. An ideal gas, a 2 kg of ideal gas. So mass is given as 2 kg. Right, solution, write the data. Mass is equals to 2 kg is compressed adiabatically. What is in by adiabatically?
Constant temperature.
Entropy. PV power gamma is equals to constant. Yes or no?
Sir.
Adiabatic process means it is a reversible. Adiabatic is also called as isentropic process, and the governing equation is PV power gamma is equals to constant from pressure P1, that is equals to 100 kilopascal. 100 kilo means 100 into 10 power 3 Newton per meter square, and temperature T1 is equals to 220 Kelvin to the final pressure P2 is equals to 400 kilopascal. This is the data given, and CP/CV values are given anyhow. Now what is asking? Calculate initial volume, right? Initial volume is asking. How to calculate initial volume? Please tell me. Just now we did similar to previous case by using equation of
MRT.
equation of state. PV is equals to M into R into T. So P1 V1 is equals to MR T1. So from this V1 is equals to mass is how much? 2 kg. R is equals to R value. How to get R value? Please tell me. You have CP and CV.
CP minus CV.
CP minus CV. Very good. Right? So indirectly you can calculate R value. So tell me R value how much? R is equals to CP minus CV. So 0.297. Check it.
0.293.
293, na? Okay, sorry. 0.293. Okay, now substitute that value. 2 into 0.293 into 10 power 3, because it is kilojoule. I converted into joules. MRT1. T1 is 220 Kelvin, anyhow absolute unit, divided by pressure 100 into 10 power 3. What is this value? Tell me this value. Anyone?
Yes, sir.
So you will get a 1.29 meter cube. So remember, always R value should be in joule. Then only you will get in meter cube. We got initial volume as 1.29 meter cube. Okay, you can check afterwards. Can I proceed?
Yes, sir.
You will get answer now. Don't worry in that. Now, so after getting final initial volume, then final volume, right? What is final volume? V2. So which type of process is it? Is adiabatic process. Between the two states, state 1 to state 2, for adiabatic process 1 to 2, P1 V1 power gamma is equals to P2 V2 power gamma. Again, how to get the gamma value?
1.4 gamma value.
Idea. So gamma you can calculate by the ratio of CP by CV.
Sir, its value is fixed, na, sir, 1.4.
No, that is for air. Gamma is equal to 1.4 for air.
Air.
Air. Okay. Huh? Tell me, CP by CV, how much you are getting? 1 by 0.707.
1.414.
Yeah, it's almost 1.4. Okay, right. Now, P1 V1 power gamma equal to P2 V2 power gamma. So what I want? I want final volume. So V2 by V1 whole power gamma is equals to P1 divided by P2. From this, V2 by V1 is equals to P1 by P2 whole power 1 by gamma. Agree?
Yes.
Please respond. Right. So from this, I want V2 only. So V2 is equals to V1 into P1 by P2 whole power 1 by gamma. Right? You have P1 value, P2 value, V1 value. If you substitute all these things, you will get V2 value as 0.484 meter cube. 0.484 meter cube. This is volume, right? Final volume. Next, what is asking? Final temperature also. Final temperature also, right? So for this, you need to use equation of state as well as the governing equation. Maybe I have discussed, again I will repeat. P1 V1 power gamma is equals to P2 V2 power gamma. Okay. Now, next P1 V1 by T1 from equation of state is equals to P2 V2 by T2. Okay. I want relation between, or else we can directly use P2 V2 equal to MRT2. T2 V2 is equals to MRT2, because P2 is known to you, V2 just now we calculated, and R is there, T2 we have. Sorry, T2 is required. So T2 is equals to P2 V2 by MR. Can I write like this?
Yes, sir.
Right. Instead of using these two equations, I can. Now P2 value is given how much? P2 400 kilopascal. P1 is 100 kilopascal. Okay. P2 is equals to 400 into 10 power 3. 400 into 10 power 3 Newton per meter square into V2, just now we did 0.484 meter cube, divided by mass is given as 2 kg, R value 0.293 into 10 power 0.293 into 10 power 3. So 10 power 3 will be cancelled. Anybody have calculator? Please tell me T2. So T2 will be equal to T2 330 around
330.
330 Kelvin. T2.
330.
Yeah, 330 is the answer, T2. That is the final temperature. Then next bit is asking work done. What is the work done formula during adiabatic process? Work done during adiabatic process equal to P1 V1.
From V1.
Try to recall. Minus
P2 V2
by,
Minus
by
gamma minus
gamma
1.
minus 1. Very good. Right? $100 Pascal. V1 value is there, P2, V2, you substitute everything, you will get a minus 156 point. Negative sign indicates that work is, please tell me, work is done on the system. Negative sign indicates that work is done on the system. Okay, now. Then after that, heat. Am I audible? Please respond.
Yes,
1 minute
sir.
only. Right? Yeah, for adiabatic process, what is the heat supply? For adiabatic, Q is equals to 0. No heat interaction. Right now? No heat added for adiabatic system. Dou Q equal to 0. Then what is asking? Change in internal energy. Right? So as we know, dou Q minus dou W is equals to du. In the absence of dou Q, that is minus 156, minus into minus plus 56 kilojoule, means during the adiabatic process. What is du? Du is nothing but U2 minus U1. Okay, so internal energy is utilized in order to do the work done. Du minus dou W. Du equal to minus. Right? So yeah, please tell me.
Arun the caller.